Laminated wood have been for many years ago, from the Pharaohs' time, but it was like 1920 when we started to have synthetic adhesive. We can make a glue lam in a way that could bear strength, load from a load capacity. Before that we have to secure the glue lam, so then we use fittings, nails and so on. And the most famous buildings, I think, in Sweden is the Stockholm Central Station, where you can see an excellent example of glue lam strengthened by nails and metal fittings, bonded by an old glue who was not so strong, called casein lim, made of milk. The development of lamination of wood was increased, enhanced in the Second World War, when there was a scarcity of steel and aluminium. So I've been working a lot about shape stability in such laminations, and also the strength of the bond line itself. I think it's possible to use that kind of knowledge in also components for house buildings. Many skilled persons work in this area. Best example is sealed cross-laminated timber invented by Gerhard Schickhoff in Graz, Austria. And we have get inspired by him in Sweden. So we have now 5 factories producing CLT panels. So CLT panels for high buildings, and also columns and beam systems are also popular with high wood buildings. So I think we are beginning of this area to use, let's say, knowledge from aircrafts to furniture, now to house buildings.
This big load frame, this is one of the biggest in Northern Europe. There are one in Borås at Rice and one in Copenhagen, and this one. And it's all brand new, this load frame. This has been discussed for nearly 20 years, this load frame, and it's prepared, the floor was prepared for this machine. And I designed this machine now for a year and put it together like a month ago, something like that. So this is brand new, and this is the first test we're going to do. And this test that I've set up right now is just for test. We're going to do tests with much bigger CLT panels, cross-laminated timber panels.
What I think is a very nice place to go and visit in Stockholm is Cederhusen. It's an area in Hagastaden in Stockholm, where they have built wood houses by the company Folkhem. And that's also very interesting because they have built over a big road called E4. So they have taken away that lousy area with the road and built a town over it. And that wood houses have a lower weight than concrete houses. They could have more floors because they have built the houses by CLT panels compared to what they have been able to build with concrete panels. So the houses at least 11 floors height, and if they have used concrete, it have been much less. At least half of it, I think. But at the same time, there's lots of people who want to use wood, because today it's the material have the best climate impact in when you want to build a house or construction, whatever. So we have to take care of the wood material in a better way than what we are doing today, so we can reuse it and use it smarter, more resource efficient than we are using today.
This panel is made out of studs and so on. We were taking the quality of this material much higher, up to C40 quality. And that will make much better mechanical behavior. You take much more force and so on, and you can make it smaller. Today you just make it of C24, and yeah, we want to go up in quality and use more of the best quality used normally. And that's because we want to see how much smaller we can do the panels with the same behavior and so on. And that's for, of course, taking care of the wood and the forest and all the material better. We use a 3D camera, digital correlation system, and this measures in 3D, and we put on a speckle pattern on the object, and then we can see exactly how it moves. Everything moves. We can down to hundreds of millimeters, we can measure everything. So that's quite fancy system, this RME system. After this, we're going to do tests with connections with CLT also, with 2 CLT panels with the connections, and try to bend it and see what force we can handle with the connections. That's also one project, and after that we're going to do a really big project with the house volumes here and test for wind load, really big. So you could take the whole space here, and we're going to push up with up to 250 kilonewtons, and we're going to have 14,000 kilos of sand up to simulate 6-story building. So the 5 stores we simulate with this sand up, and we're going to test what's happening when we push it. So on that we're going to have double of this camera system and a lot of sensors, and everything is going to big acquisition of data so we can use for the future for research and so on.
Yeah, okay, so this is what we see mainly. One piece of wood, yeah, whatever. The contrast is very good. Every pixel in this camera is very sensitive to a change in temperature. So what we do here with this technique here is that we fix the temperature to two different known temperatures. One temperature is the wet bulb temperature. That is the normal way to measure the humidity. And we know what that is in the dry because we measure it with a ordinary temperature sensor. And then we have the dry bulb temperature. So we have these two fixed points. And with these two measures in the camera picture, we could quite precise measure the board temperature. So the board temperature will be somewhere in between this wet bulb temperature and the dry bulb temperature. The production needs to be high, so you don't have the time sometimes you need to go down quick as possible with the right quality on the board. So this could be a technique where you actually can see something more.
A piece of wood can be used in many ways in a construction, and there will be different forces acting on it. So you have bending strength, it will bend down, and then you have compression when you take the force like this, and compression perpendicular to the fibers, pressure like this. Every country had their own grading rules, and now with the CE marking and 338 there are tabulated values, so each sorting grade corresponds to a certain C class or D class if it's broadleaf wood in the table. So you can sell the wood in any country in Europe because we have the same classes.